Good afternoon, everyone. Big thanks to UHN and Office of Research Trainees for inviting me today to talk to you about something that I'm very passionate about, which is data science. So let me start by sharing some slides with you. So about 2 years ago, I started a platform called the Coding Hive, which offers data science workshops for high school students, for university students, and for professionals. And the idea behind these workshops is that we bring people together from different academic backgrounds and we teach them data science. We also work on developing AI applications. We do that by breaking down AI into simple components. We introduce people to coding, statistics, data analytics, and working with big data. So if you're interested to learn more about the workshops, you can check out our social media sites, or you can even check out our websites to learn more about upcoming workshops. Also feel free to send us any questions that you have, or send me any questions that you have by contacting this email right here. So today I'm going to be talking to you about data science, specifically becoming a data scientist. And I decided to break it down into 3 sections. So the first section is going to be an introduction to data science. What do data scientists do and what kind of applications do they work on? And then we'll move into the learning paths that you can take to become a data scientist. And in that process, I will tell you about my personal journey of how I transformed from being a bioinformatician to data scientist. And then finally, we're going to end it by talking about how to land a job in data science and what kind of things can you do to elevate your application and your portfolio. So what is data science? Data science to me is really a process where you can collect large amount of data, use that data to learn insights, and then take those insights and make decisions. This so far sounds like data analytics. So how is data analytics different from data science? It's different in the sense that these decisions that you're making are on data points that you have not seen yet. So you're performing some sort of prediction. Now, when you're talking about learning, I am specifically talking about a field in computer science called machine learning. And machine learning is simply an algorithm that is using a lot of math and statistics, and it's implemented in a programming language, whether it is Python, R, Java, C, it doesn't matter. The idea is that these algorithms are learning these insights from your data or finding these insights without being explicitly told where to look within the data set. And that is what makes machine learning so powerful. Now, there are a lot of different machine learning algorithms, and they vary in their complexity, in their performance, and their interpretability. We can start with things that are very simple and easy to understand, like regression. So when we talk about linear regression, logistic regression, we can also move to things that are a bit more complex when we talk about decision trees, ensemble methods, such as random forest, XGBoost. And then we can even take it a step further in terms of complexity and talk about neural networks and deep learning. So deciding on a specific machine learning algorithm to use on your project depends on many factors. It depends on what kind of problem you're trying to work on, what kind of relationships exist within your data sets, and also what kind of data you're working with. Data sets are usually split into 2 types. So there's structured data and there's unstructured data. Most of you here in this room have probably worked and analyzed or interacted with structured data at some point. And structured data means tabulated data, rows and columns, whether it's a database table or just an Excel sheet. Those are structured data. But most of the data that's available out there is considered to be unstructured data. So here we're talking about videos, we're talking about pictures, we're talking about voice, we're talking about open text. And most of the data available out there is unstructured. And there's deep learning, specifically neural networks. They work really well on solving problems that involve unstructured data sets. And healthcare specifically, I'm sure a lot of you here are working in healthcare. There is a lot of unstructured data that we're sitting on, and there's a lot of potential to extract insights from this data that is yet to be done, which hasn't been done yet. Now, what do data scientists do? So data scientists, I think of them as problem solvers, storytellers, people that interact directly with these algorithms. And what they do is they try to use these algorithms to solve a problem and then tell a story behind how they solve the problem and the insights within that data. Now, there are various ways that they can do that. They can either develop an algorithm from scratch, or use something that already, an algorithm that already is existing, and simply just tweak it and tune it to fit your specific project or data set, or even use platforms, point and click, where you upload a data set and then you walk through that process. But the idea is you're interacting directly with these algorithms, and you have to have a good understanding of how these algorithms work. Now, in terms of applications of data science, it's massive. So not only in healthcare, but banking, a lot of banks are using data science and have data scientists employed there. Education, manufacturing, government, retail is spending a lot of money to incorporate data scientists and data science projects in their work. Now, what kind of products are data scientists working on? There is a lot of products, a very wide spectrum of products that they're working on. Here I'm just mentioning a few of those examples of those products. For example, speech recognition, image recognition, object detection within images, chatbots. A lot of retailers are using chatbots on their websites. Predictive analytics is a big component of data science. So whether you're talking about forecasting, time series analysis, any sort of prediction is widely used in data science. And also text classification. So if you've ever heard of natural language processing, just trying to take languages and text and try to make sense of them. That's also a big field in data science. Now, as a data scientist, you can choose to focus on one of these products or one of these fields and specialize in them, or have a general knowledge in many aspects of, or many products mentioned here. So it really depends on your academic background. It depends on the company that you're joining and what kind of projects you've been assigned to. So just to mention a couple of examples, I'll bring examples from my actual experiences. So like I mentioned before, I worked in healthcare, specifically in cancer research. How did we use machine learning in cancer research? At the Ontario Institute for Cancer Research, what we did is we did genome sequencing. So reading the human DNA, and we collected samples from the tumor and from normal samples, and we tried to find out, we pass all that information, all the DNA bases that we sequence, we try to pass them to machine learning algorithms to help us identify if there are any patterns that could distinguish people who have cancer versus people who don't have cancer. And in hope to build a biomarker, which can help us figure out what the probability of getting, so diagnostic biomarker, prognostic biomarker, to help us figure out what is the probability of getting cancer, what's the probability that cancer will relapse, what is the probability of getting an aggressive type of cancer, and so on. And all of that information from those biomarkers, we are hoping can be used to tailor the treatment for those patients. So that's one application of AI or machine learning in cancer research. Now, I also mentioned that I work now in banking, specifically RBC. So right now where I work is a team called Risk Modeling and Machine Learning. And there what we do is we also build models to predict risk. But the risk here is a bit different from the risk in healthcare, in the sense that we're trying to predict the risk that the client will default, or maybe a client will not pay their payments, or if they're high risk, how much money or what product should we give them, whether it's a credit card or mortgage, and so on. But the idea is the same. We're building a model to perform some sort of a prediction on data set that you have not seen yet. Now, outside of my work experience, I just wanted to bring in a few examples of data science and how it is utilized in healthcare and outside of healthcare. So last year, for example, deep learning or neural networks were used to to get insights of lung cancer from histopathology slides. Other things deep learning and neural networks are being used for is to extract insights from x-rays, for example. And I'm putting a link here. You can click on that link. The previous paper was actually a research paper, so feel free to go through it and find out how it was done. This is a simple tool that you can click and then see how it works. Now, a lot of companies are investing into data science because they have seen, and it's been shown that incorporating big data actually increases the retail's operating margin. And this was work that was done by McKinsey. Back at the time, it showed that it increases by 60%. But the idea is a lot of companies are investing in creating data science team and data science products. And one of them is Facebook. They have invested a lot of time into generating an application called Deepface, or an algorithm called Deepface, which is one of the best facial recognition algorithms that are available now. It can detect faces up to 99% accuracy, which is quite insane. In addition to that, Uber has been investing a lot of money and resources by developing self-driving cars. To be honest with you, I never thought I would live to a day to see a self-driving car or even be in one. I always thought this was something so futuristic. It will never happen in my lifetime, but it is actually happening, and a lot of research is being done there. Now, set aside these American companies and organizations within Canada, and specifically within Toronto, there are a lot of companies and organizations that are doing amazing work in terms of data science. There are data science teams that are growing and AI products that are very, very impressive. And I'm mentioning here a few. I might have missed other organizations, so I'm sorry if I have, but these are some organizations that I have interacted with and I've seen do a lot of great work, including organizations like SickKids, UHN, OICR, Deep Genomics. A lot of these are located, a few of these are located at the Mars Discovery Center, a lot of startups there too. But these companies specifically, they are trying to use a human genome to learn more about diseases in general, whether it's cancer or other diseases in the case of deep genomics. And they're doing that by using data science and AI. Another great example is Blue Dot, which is a startup in Toronto. I'm not sure if you've heard of, but they use big data and machine learning to predict the spread of pandemics. So during COVID, they were trying to collect as much information to figure out where COVID is going next, how fast it's spreading, and what city is it heading to. And all those insights will be shared with public health. So great work. Highly recommend you check these websites to figure out what kind of product or projects those data scientists are working on. Outside of healthcare, of course, there is a lot of work that's being done in banking and retail. So almost every single bank right now is or has a data science team that is definitely growing. But in addition to that, some banks are actually seeking for advanced AI research. So if you haven't heard of Borealis, Borealis AI is an AI research company that was acquired by RBC a few years ago. And they're doing a lot of PhD candidates that are working there, working on a very advanced AI research products. The same thing happened with TD Bank. They acquired another AI research company called Layer 6. Same idea. But in addition to banks, like I mentioned, Shopify has a growing data science team. Wealthsimple, Loblaw Digital is also growing. Again, I highly recommend that you check them out. And the idea is they're using big data, they're collecting information from the clients and applying machine learning to really give that customer that tailored customer experience. So they're trying to use or apply machine learning and use data science to tailor the customer experience and enhance the customer experience. Let's see. So what does a day in the life of a data scientist look like? What do I do on daily basis? When I talk about the day of a life of a data scientist, I'm really also talking about the data science workflow. So almost every single project I was involved in data science project, whether it was in healthcare or in banking, it had a very similar workflow. And that workflow usually started by having a meeting, whether that meeting was with your PIs, principal investigators, or that meeting was with business stakeholders. But the idea is you're engaged in meetings with stakeholders to define a problem. You're trying to search for the new challenge, the new problem that you can use big data and machine learning to solve. Once you identify a problem, you spend a lot of time. I'm sure you've heard a lot of data scientists say that, doing something some people call data cleaning. I like to call it data exploration. Some people might not enjoy this process because it's mundane. You're just cleaning the data. However, the way I look at it, I find that it is one of the most important steps of the data science project, because what you're doing is more than just data cleaning. You're actually getting a sense of your data, where it's coming from, what assumptions are there in your data, what biases are there, and how can you reduce these biases. In addition, for example, if the data is missing, why is it missing? How can you retrieve it? How can you impute missing data? But the idea is you're really learning more about your data set. And you're learning to create features that will be meaningful. And the only way you can do that is by exploring the data and spending a lot of time exploring the data. And also in that process, what you're doing is you're trying to figure out, remember how I told you there are a lot of machine learning algorithms, you're trying to get a sense of which one of these algorithms would work best for your specific data set and for your specific project. Once that happens, and you spend weeks, if not months, doing that, you are ready to apply machine learning, apply those models, tune those models to fit your data set, and perform predictions. That process really depends on your computational resources, how many resources do you have, also how big your data set is and how complex it is. It could take days, could take hours, it could take weeks. But once the modeling piece is done, then that is usually followed by the communication part. And in healthcare, that could mean you presenting your work to your colleagues, writing a publication, even pushing it further to developing maybe a biomarker and publishing the biomarker, taking it to a clinical trial. All of that is part of the communication process. In terms of business, banking, retail, that could be developing a product, deploying the product, which means implementing it, turning it into something, a product that can that clients or customers can actually interact with, and at the same time presenting all of this to the business stakeholders. This piece is so crucial and so important because if you do not communicate what you've been working on, or if you do not communicate it properly, then all of the steps from 1 to 3, they go to waste. So it is important that you, if you're in business, for example, in a bank, you explain what you've done, you break it down. You're dealing with different audiences. Some business people might not have a full knowledge of what AI and how it works. So you need to break it down in a way that you can actually help them gain an appreciation of how AI and how the investment that they've put into these AI platforms resulted in a lift in performance or a lift in profit. So if you have any questions about this, I guess we'll save it till the end, and I can answer more details about the day-to-day life of a data scientist. And this leads me to the main purpose of, or the topic of today's talk, which is really becoming a data scientist. So how do you become a data scientist? If what I've mentioned so far is of interest or something that you've considered in the past, what kind of learning path do you take to become a data scientist? I'll start very briefly telling you about my journey and how I went from health into banking. So, and then I'll make more I'll talk about more general concepts of how you can get into data science. So for me, my undergrad was in biochemistry. So it was something very different from what I'm doing right now. But it was during my last year of biochemistry, I took a computational biology course, and it showed me how programming and softwares can actually be used to answer biological questions. And I fell in love with that. However, I faced a problem, which was I did not know any programming at the time, zero programming. So what I wanted to do is I wanted to, after I graduated, because it was too late, it was fourth year when I took that course. After I graduated from biochemistry, I wanted to go and learn programming. And I went to Seneca College for a year, and I did their bioinformatics program. It was a great program, and they taught me how to program. I took that, and while I was learning programming, I was also, and becoming a bioinformatician, I was getting a sense of how important statistics and math was for a bioinformatician. So after I graduated, I went to the University of Toronto and I did my master's in biostatistics. So again, that's stats knowledge. When I finished university, or U of T, I had stats and I had coding and curiosity of research from my undergrad. So I really kind of wanted a job that would combine all of that together. And at the time, next generation sequencing was a very hot topic. And it was one of the only sources in healthcare that was providing big data. So there was a lot of potential of using big data in NGS, next generation sequencing. So I joined OICR, which was one of the first institutes that invested in buying very expensive sequencing machines to generate a lot of data, sequencing data. And there's a lot of information that they needed to make sense of. So it was then when I started kind of applying the coding, the stats, and the machine learning piece started happening there. So I was very curious. I went to Ryerson. I sat into classes. I wasn't able to register. I went to TFT and I sat into classes. I read a lot of books. The team that I was working for had a lot of PhD candidates. They did a lot of journal clubs. There was a lot of reading. There were a lot of conversations that were happening, and the learning was happening through that. So it was really self-learning. I picked the resources and I tried to seek out that machine learning knowledge. And it was at that point that data science, I transitioned into data science. So to me, it wasn't really a certificate that I took and I just became a data scientist after a year. It was more of a natural progression or a journey to get to that point. Now, you might wonder, why did I want to switch after spending so many years in healthcare? I spent about 7 to 8 years in cancer research. I really wanted, after I gained all these skills, I really wanted to challenge myself and see if I can take those skills and actually apply them somewhere else. Apply them to a field that was so different from what I was doing, and see how transferable are those skills. And with challenge comes excitement, with challenge comes obstacles, and I was really excited to go through that experience. So I applied for RBC, and I also, the other factor is I wanted to work with big data. So one of the limitations working in healthcare at the time was the fact that the number of patients that you had, the data sets were minimal. They were restricted because sequencing was expensive. More recently, there are more consortiums, worldwide consortiums that have increased the sample size. But at the time, I was limited to the number of samples I was working with. And I wanted to work with big data. Yes, the number of features that I was working with was massive because of sequencing, but the sample size was small. And a lot of the cancers that I worked with were rare cancers. So again, you can imagine the data sets were smaller. So another reason why I wanted to try banking was the fact that banks, they have a lot of transactional data and they've been sitting on data for a very long time. So I really wanted to kind of deal and interact with big data and see how model development can be different or is different when you work with bigger data. So I've been with the bank for 2.5 years, a bit over 2.5 years now. And the reason why I'm mentioning this is, again, I wanted to highlight that there were a lot of skills that were transferable, whether you work in healthcare, whether you work in banking, whether you work in retail. I will highlight some of those skills, and in hope that you can take those skills and either apply them to wherever you're working, or if you're thinking of transitioning into another field, then you can take those skills with you. And ultimately, those skills are actually what define data science. So, for example, some of these skills are big data analytics. So, just working with big data, whether it is dealing with SQL databases, writing efficient SQL queries, or doing things more like Hadoop and Spark. But the idea is being able to deal with big data and parse big data. Another good skill to have is data visualization. That was very crucial in healthcare, very crucial in banking. Because you're dealing with big data, sometimes a simple plot can tell you so much about a relationship between variables if it's done well. So it's a very good skill to have wherever you are. Computer science was so crucial because understanding computer science means you understand those algorithms, how they work, and be able to explain that to whoever asks you any question, whether it is validators in the team that you're working for, or even the stakeholders that you're working with. And to gain full understanding of these algorithms, you have to have knowledge in math and statistics. Very important, not only to understand the algorithms, but also to be able to assess the performance of your models. So a lot of the programs that you're using, you can run a stats test. It will just spit out some numbers. It will not tell you if you're running the appropriate test. It will not tell you what the outcome means or what it signifies. It is really your responsibility as a data scientist to understand what each test is testing, what are the assumptions, what is the p-value, what does it mean. So stats and math, very crucial. And really, people who have all of skills or experience in all of these fields, I'm sure you've heard this term, unicorn data scientists. They say they're hard to find, but more now than ever, people are learning about all of these skills during their undergrad, during their grad, and it really, like, to see the diversity in the background, academic backgrounds for a data scientist, it's really nice, because you see people that have done undergrads in computer science and then maybe did a master's in statistics, or even an undergrad in science and then they did a master's in statistics. It's just a mix and match, and some people have maybe more in-depth knowledge in one of these aspects versus the others, and that is totally fine. It's good to have that diversity within a data science team, and have one person who is more of an expert in one specific field versus the rest. Now, when people were asked about, so there was a survey that was done by Kaggle, we'll talk about Kaggle in a bit. They asked about 8,000 data scientists, what are the tools that you use on a daily basis? The top two were Python and R. So the reason why I'm highlighting this point is just to emphasize how coding is so important in a data scientist's life. So coding, it doesn't matter whether it's Python, it doesn't matter whether it's R, as long as you know coding, it is very important. In academia, when I worked before in research, R was important. I coded everything in R. When I moved to the bank, it's a mix of R and Python, but I'm using a lot more Python now than I have in the past. But the idea is, if you're new to this field and you don't know what to do, learn any programming language, whether it's R or Python. If you're planning on staying in healthcare or doing research, then R is great. If you're planning on moving into an industry or work for an industry, then most likely that industry is going to be using Python. The switch is not hard. It can be done. Just learn something and learn it now. Again, if you have any questions about all the other tools, I'll talk about them, not right now, but we can save that for questions later. Are we good? I feel like I've talked a lot, and hopefully I'm still connected. Can someone confirm that I'm still online? Please.
I can hear you.
Excellent. Okay. That's good. I would have been very sad if all of this went to waste and I wasn't online. Okay, perfect. So let's talk about learning resources. So how I get that question quite a lot when I teach, when I run workshops. A lot of people ask, how do I become a data scientist? What paths do I take? There's just too much material out there. I don't know where to begin. And I can understand that, because data science is not just one thing, it's many things. So I can understand frustration of not knowing where to begin, especially if you don't have any of these skills. But usually what I say to people is ask yourself 3 questions. How much time do you want to allocate to learning? Do you want to do it part-time? Do you want to do it full-time? How urgent is this? Also, how much money are you willing to spend? Do you want the learning to be free, or do you want to spend money in the learning, and how much? What's your budget? And the third thing is, which is the most important thing, is what are you trying to get out of this learning? Are you already a programmer that you're interested in applying machine learning to your data set? Or are you, so you're learning this to just get promoted in your position? Or are you learning this because you want to do a career switch? You don't know programming, you don't know the stats, and you really want to do that switch. So that's the quality. That if you answer all of these questions, write them down, that will give you a better sense of what path you will take. So for now, what I'm going to do is I'm going to give you like a preview of 3 different paths, academic paths within Canada, specifically within the Toronto or GTA area, that you can take to become or help you become a data scientist. And by no means, these learning paths, you don't have to take them to become a data scientist. I feel like coding and stats are essential, even if you're in data analytics, even if you're a scientist that is not even working with data science or doing programming. But learning about this helps you communicate better with data scientists or people that work with AI. Also helps you, if you're a researcher or a scientist, help you gain a better understanding of, is this feasible? Is my question feasible? Is it doable? A lot of times getting that knowledge can be helpful in estimating how feasible these things are, or the problems or challenges, and if they can be done with machine learning. So let's start with something very simple. Let's say that you only have 10 to 30 minutes a day of learning that you can do. You're very busy. This is something that I use quite often. This would work well for people that might have background in coding already, and they just want to learn new skills on a daily basis. Blogs were very, very useful in my learning journey. So I'm mentioning a few here: Towards Data Science, Machine Learning Mastery, Our Bloggers, Explain the AI, Analytics Video. I learned quite a lot from these blogs. And I would, during lunchtime, during coffee break, I would just browse through a blog post. And a blog post in any of these blogs, usually it takes a concept. So it says, okay, this is random forest. Let's break down what random forest is. Let's break down how it works. And here's a code of how you can run random forest. And it's a very quick way of just adding a skill to your portfolio. You can take it now and then apply it to your specific data sets. I'm not saying you're going to be a master at that, but it really is the first step to learn something, and then you start questioning. Then you ask yourself, oh, and now how do I tune this algorithm? What happens if I change this? What happens if my data set has this, with this algorithm still work? So then you start asking questions and then seeking more, either blog posts or specific people or books and so on. So great starting point is blogs. Now, let's say that you do not have any coding background. Then I would highly recommend you do online courses, because the first thing that I would do is learn either Python or R. And there are a lot of, maybe too many online courses that are available. And usually it's the challenge of figuring out what course should I take. And with online courses, there is the option of paying if you want the certificate, or you can just do them for free if you do not want the certificate. Commitment will be an issue. A lot of times, I personally am guilty of it. I've started an online course and I just got so occupied and so busy, and because I'm not paying for it, I just get distracted and don't finish it. One way around it is, I found that if you find other people or colleagues, you do some sort of study clubs and do these courses together. And this way, they will remind you, they'll make you feel guilty if you miss them, which is a good motivation. But these you can spend weeks, you can spend months and learning them. And there are a lot. I recommend all of them. It really depends on what you're interested in. So if you want something that has affiliation with universities, Coursera is great because it has a lot of affiliation. It has certificates that you can show to your supervisor or whoever you're applying for. Now, I'm just highlighting a few courses that I recommend. So they're coming from Coursera, Udemy, EDX, and it's a mix of introduction to Python, introduction to R, statistics, and machine learning. So this is just few of many, many options out there. At the end of the day, it doesn't matter what course it is that you take it. Whether it's good or bad, you're going to learn something from it. At the end of the day, you're going to pick up something that you did not know before. Now, if you are serious about getting into data science and you want to dedicate the time to become a data scientist, this is something that is available now that was not available when I got into this field. There are a lot of universities, the School of Continuing Studies from these universities are offering certificates in data science. And I am mentioning a few here, such as University of Toronto, York, George Brown College, University of Waterloo, Ryerson. To be honest with you, the one that I've heard great feedback from is the University of Toronto. I don't know if it's because I live in Toronto, but a lot of people that have taken this certificate, they've given me great feedback about how the instructors are amazing and the quality of the courses are so good. These are evening courses, in part-time. It could take up to a year to finish them. There's usually, in all of these certificates, there is 6 to 8 courses usually, and those courses are a mix of introduction to Python, introduction to big data, statistics, and machine learning. Those are the topics. But yes, so feel free to check them all out, see if that's something that you're interested in. Also, financially, these are a bit more affordable compared to other data science training. So there are also other companies that I'm highlighting here that offer data science certificates that could be part-time, could be full-time, could take weeks, it could take months. BrainStation, Juno College, this used to be HackerU, they changed their branding recently, General Assembly, WeCloud Data, and the Coding Hive, which is a platform that I started. With the Coding Hive, we usually offer just very short workshops. They usually are very affordable. They used to be in person before COVID, 2 days, where we pick one specific algorithm, we work on it together, and we go over the coding for beginners. We show them how to turn it into an application, how to deploy the application. We talk about the theory, we talk about the math behind it, really break it down over 2 days. So these are very short, very specific workshops. That hopefully we'll do some with ORT. There are plans to do that in the future, so we'll definitely let you know. But feel free to check these. So these are they are a bit more expensive, but it really again depends on how dedicated you are and how willing you are to become a data scientist. And these work well if you're working for a company, so you're not really funding it yourself. Maybe the company will be able to fund it on your behalf. So let me look at time, 2:50. Okay, so I'll quickly just talk about how to land a job in data science, some tips that I have for you. How are we doing, Jason? Do I have time? Can I continue?
Yeah, we were initially scheduled until 3, but we can go a bit longer if there's more questions, just to allow for the question and answer period after. So please take your time.
Sounds good. Yeah, I should be done by 3. So one thing that I highly recommend, whether you are currently looking for a job or even in the process of learning to become a data scientist, is to keep an eye open for jobs, even if you're not looking for a job. It is good because it gives you a sense of what the market is looking for, what kind of technologies, what kind of skills, what kind of very specific even within machine learning, what kind of machine learning algorithms are companies looking for. And this you can use actually as a guide to figure out what courses you should take and also what skills you want to build up. And this way you're actually building up those skills so that in a year or two, you will have all the skills that are in high demand in the market. Now, to do that, I would check LinkedIn. for jobs, or even to connect with people that are maybe recruiters, maybe managers, or people that are in the position to hire, just to get a sense of what they're looking for. And Indeed is also another good location to look for jobs and figure out what is available. Glassdoor, the reason why I mention it, is a website that tells you about the company and how good the company is. Because a lot of times, maybe the company sounds of interest to you, but once you start reading about people that work there, and people usually they leave reviews after they leave the company, you will get a better sense if this is a good fit for you. And it's all about that. It's all about you being comfortable in that environment. I highly recommend, if there is a company that you're interested in, check Glassdoor just to see if it's really a good fit for you. Now, let's say that you're doing that. At the same time, there are a few things that you can do. Very common sense to keep your resume up to date. But more importantly, nowadays, I feel like you should keep your LinkedIn. So if you don't have a LinkedIn account, it would be a good idea to create a LinkedIn account, keep it active, share your research projects, what you're working on, with limitations, of course. Don't share everything, what you can share. But the idea is keep it up to date, because recruiters usually, the first place they look at your LinkedIn profile. The other thing is that I highly recommend is start a GitHub account. So for those of you who are not familiar with GitHub, it is really a repository for codes. So this is a place where people share code, developers share code. So if you have any code that you can share, obviously not the codes that you're working on for your projects, but any side projects, if you have any code, and it doesn't have to be elaborate, the idea is sometimes you apply for a job, they do ask for your GitHub account. And they want to see what your coding style is like, whether you comment your code, is it clean, is it efficient? So it's nice to have that ready so that when they ask you, they can just go through your codes. And which leads me to the next point, which is side projects. So it's really important to have some side projects for multiple reasons, because obviously, with the work that you're doing right now, you will not be able to publish it on GitHub. There are a lot of restrictions and privacy, but you can pick up a data set from the side, and Kaggle is a great website. So create an account in Kaggle. I'll talk about it in a bit. Create an account, download a data set. There are so many data sets on Kaggle, and work on something on a small project. It doesn't have to be elaborate. Just work on a small project and then publish that. Publish that work on whether on Kaggle or even a blog post. Now there are a lot of, whether it's Medium or Towards Data Science, these blogs allow people to contribute material. So you can talk about what you've done, how you've done it, and any struggles that you've encountered. And people do care to see that you do things. You do things that are maybe you're not familiar with. So maybe if you're in healthcare, you're doing projects that are not health related. And it's interesting because it's exciting to do something different from what you do on a daily basis. It's a good challenge that people usually look for. So this is Kaggle. If you haven't seen it before, it's a competition website. It has a lot of data sets. So just go to the data set section. The only thing is, if you want something unique and a project that you and only you will work on, then this will be challenging. Because a lot of times what people do is they usually pick a data set that has been used by so many people. So you see that in interviews, it becomes so redundant. You've seen that data set. Many people have done that in the past. And that's okay. You're learning from it, no matter what data set it is. You are learning, you're applying machine learning there. So that's totally fine. But if you're looking for a unique data set that no one else has, I'm a promoter of Toronto Open Data, and I feel like not many people know of Toronto Open Data. So the City of Toronto has actually done an amazing job in releasing a lot of data sets in the City of Toronto, whether it is restaurant health inspections, whether it is TTC, tracking times. So there's a lot of cool data sets that you can take, combine, and they're local data sets. So not only you'll stand out because you're doing something unique, but you can actually turn it into an application that could give back to the community. So try it out. If you have questions, feel free to ask me. And one of the last things I'll talk about is the interview process. Most of the data science interviews really have are broken down into 4 components. So there's usually a live coding session. And I understand how stressful that is. It even stresses me out because you are doing something that you do not do on a daily basis. And usually this happens if it's in person, you do it on a whiteboard. If it's online, then you do it through some platforms that will allow the person who's interviewing you to see you as you code. The idea is they really want to hear you out. As you are coding, they want to see the logic that you're using when you're coding. And that's something that you do not do as a coder on a regular basis. So my tip to you is get a whiteboard. I have one at home, and I use it because I want to get comfortable with teaching, but also it is a great practice. Practice at home, even if you're not even considering interviews. It's just a great process to practice coding on a whiteboard and explaining your chain of thoughts. Another section that is usually asked in interviews is statistics and probability. So brush up on your probability knowledge and read books, check blogs, make sure that you know test statistics, what the assumptions are, what they mean. So that's another component. Machine learning questions. So if you have used machine learning in the past, in any of the projects, make sure you know them, make sure you know them well, because they will ask details about the algorithm that you've used. They will ask how you tune the parameters, what is this metric, what happens to the algorithm if you change this. Depends on the company, they might even ask you to derive or write formulas that are involved in some of these algorithms. It really depends on the company and the role, but know it well. The last component is really domain knowledge. So like I mentioned, a lot of these skills, the first 3 are transferable skills, but the domain knowledge is very specific to the company that you're joining. So for example, in banking, when I got interviewed, I was asked banking questions, so I had to do my research. When you apply for any company, get to know their products and get to know the products well. How do they work? What kind of challenges they might face in developing a product? Because they will ask you product management questions. So just make sure you study the company very well. And I'm just going to leave you with the last tip, which is networking. Network. I cannot emphasize how important networking is, because with networking, you are getting an access to job postings that maybe have not been posted yet. Usually people ask colleagues if there's anyone that they're interested in and they trust to apply for a position. So get to know people that work in data science. And again, even if you're not interested in applying or changing careers or fields, it is good to network, because that gives you a sense of what others are working on, what other companies in Toronto are doing, and how are they applying AI? And is your company doing something similar? Are you behind? Are you ahead of everyone else? It's really nice to gauge. So here I am mentioning very specific networking events and meetups that are specific to Toronto. So AI Geeks is a great organization where they do monthly meetups. They used to be in person, now they're virtual. We've actually hosted a lot of workshops with AI Geeks as well. But AI Geeks is the place where people come from different companies. Uber have sent representatives to talk about the research that they do, and they go in depth talking about the research that they do. So it's a great exposure there. Tech Toronto is another great meetup. I believe it's happening virtually right now, where you get to meet other people from other companies and learn about what they do. Toronto Machine Learning Summit, another great place. Aggregate Intellect is located at the Mars district, and the founder used to work at RBC, and he was a guest in many of the workshops that I had. Great guy, great group. And what they do is, if you're a PhD candidate that is interested in learning very advanced AI research, you already know the basics and really want to take it further, you want to dissect AI papers and go through the deriving, how to derive a lot of these formulas, then Aggregate Intellect is a great place to go. Check their website, you can go to there and attend their events. it's very advanced work. And then cognitive class is something that is offered by IBM, and that's when I was transitioning into data science. I used to attend their meetups, and their meetups were nice because they did coding sessions. So I would go there, and sometimes they were IBM related products, other times they were not, but it was just nice to go and spend an hour or two learning from a data scientist that worked at IBM how to develop a chatbot, how to use some of the IBM services to do that. I believe they're doing them virtually now, so check them out. And finally, I'll leave you with Elevate, which is a tech festival. I don't know if you've heard of. I have attended it many times. It is, I wouldn't call it, it's not as techy as the other organizations or meetups that I've mentioned. They don't break down AI research papers. But the idea is companies come and say what they're working on. It's really meant to be a networking event. It's a whole week, and you go, you talk to people, you mingle with other data scientists, and you just learn what companies are using an AI, and you can go talk to their representatives. Again, I think they are making an announcement next week to announce that they're doing it virtually, but keep an eye for that as well. With that, I am going to end this talk. Perfect timing, 3 o'clock. I hope I did not go over time. And I'm putting the links again. Feel free to ask me questions now. I'll be here. If you have any questions, specific questions that maybe I have not addressed. And if not, please check any of these websites. I think we are working on developing a workshop that is specific to healthcare and genomics. So we'll keep you updated once we decide on a date and also the topic, but we'll send you an invite. Thank you.